Welcome guys to the working of Mathematics Paper 1 of 2018 GCE. So we are going to work out this whole question paper and we see how we can help one another. So we'll start with question number 1. Question number 1 is a simplification question. So it says we have to simplify this expression here. So the expression under simplification is here: 4 open brackets x plus 2y close brackets minus open brackets 3x minus 8y. So how do we simplify? What is the procedure? So you pay attention to the procedure because you might apply the same procedure on another question. So the procedure, first you have to open the brackets by multiplying what is outside the brackets with everything inside it. So here we did it: 4 by x, that is 4x, 4 by 2y, that is 8y, negative by 3x, that is negative 3x, negative by negative 8, that is positive 8y. So you've opened the brackets in this way. The next step, you have to collect the like terms together. What we mean by like terms, they are those terms which have the same variable, and variable we mean letters. So we can see terms which have the same variable is 4x as well as negative 3x. So you get your 4x and your negative 3x here, 8y and your positive 8y, like that. After collecting the like terms, you have to compute them, you work them out. So 4x minus 3x, that is x, 8y plus 8y, that is 16y. Since at this juncture you can't further simplify this expression, you leave that as your final answer. Question number 2, you are taught to evaluate. So evaluating is the word which is used to solve. Instead of saying solve, you are taught to evaluate. It's the same thing. So you have to solve this. How are you going to solve them? 27 is raised to a fraction, and that fraction is 2 over 3. This is the tip that you need to know. You need to know that 3 is the denominator and 2 is the numerator. Now, the tip here is that when you start working it out, this 3 becomes the root, so it becomes the root of 27. So since it's 3, it will become a cube root of 27. Then the 2 will become the power. So here we are saying cube root of 27 raised to the power 2. And this is the next step which is shown here. Cube root of 27, it is actually 3 raised to the power 2. The final answer is 9. We come to the third question. The third question, it reads: a straight line passing through A, which is a point 3, 2, and B, which is a point 5, y, has the gradient negative 2. Find the value of y. So A is 3, 2, B is 5, y. Then the gradient we've been given, the gradient for this line, it is actually negative 2. So how do we find the value of y? For us to find the value of y, we have to recall the formula for calculating gradient of a line. Gradient of a line is equal to y2 minus y1 over x2 minus x1. So with the coordinates that we have, our y2, which is just y, that's the y we are finding. Then our y1, that is 2, so y2 minus y1. x2, that is 5. Then our x1, that is 3, so 5 minus 3. Then our gradient, we've been given that it is negative 2. So we're going to have negative 2 is equal to y minus 2 over 5 minus 3. It's actually 2. From here, we simply cross multiply. Y minus 2, you multiply it by 1 there. You're going to get y minus 2, which is equal to 2 multiplied by negative 4. You are getting 2 multiplied by negative 2, sorry. You are getting a negative 4. Working out this equation, negative 2 comes this side and becomes a positive 2. Negative 4 plus 2, the answer is negative 2. So that's the value of y. Your y is negative 2. We move on to question number 4. Question number 4, it is factorizing completely. So this is one of the simplest form of factorization that you can encounter. We've got this one, which is actually falling under the difference of two squares. We've got another one, which is a quadratic one. So we are lucky that we've made this one. As you continue watching our videos, you get to know how we can factorize the quadratic ones and the other ones not here in this paper. So how do we factorize this one? First of all, we start by factorizing what is common, which is 5. So 5 here, you have x squared, 5 there, you have 1. Then you come to find out that x squared minus 1, it is actually a difference of two squares. Why a difference of two squares? Because this x squared has got a perfect root, which is x, and 1 has got a perfect square, which is 1. So we have x minus 1 and x plus 1 with the 5 outside of each bracket as our final answer. So that is how we go about this factorization. Let's move on. We come to question number 5. Question number 5, it is actually a set. You are given a Venn diagram. Then you are taught to describe this Venn diagram using set notation. Now, describing this Venn diagram using set notation, you can see that the shaded part here, it is actually representing A union B. But this A union B, it is not complete because of some other parts which are not shaded. And these other parts which are not shaded, they are actually the complement of C. So it turns out that the shaded part, it is representing A union B intersection C complement. A union B intersection C complement. That has to be our final answer. Question number 6, it is a matrix. You are told to express the given matrix, which is C, that is matrix C, and matrix D, you are told to express as a single matrix. So expressing this as a single matrix, there's nothing magical you are supposed to do. You are just going to multiply these. And when multiplying, we know that we follow the rule, which is row by column. Again, this row by the same column. So let's start. Row, our first number in this row, that is 5, multiplying by the first number in the column, 1. So 5 by 1, that is 5. Then negative 1 multiplied by negative 2, that is 2. So 5 plus 2, you are getting 7. You come to the down row. The down row, the first number is 2. You're going to multiply it with 1. So 2 times 1, that is 2. The second number is 1. 1 times negative 2 is negative 2. So 2 minus 2, you get the answer to be 0. So 7 and 0 down, it is expressed as it is the expression of a single fraction of these two. Did I just say fraction? I'm supposed to say matrix. So 7 and 0 down, it is an expression of a single matrix as a result of multiplying these two given matrix. And this becomes your final answer. Let's move on to question number 7.